Hello, everybody, and welcome to our first podcast. Um, in this podcast, we're going to be talking about physics of ghosts, or the quote physics that we have discovered. And we are not entirely sure if this is 100% correct, but according to our resources and base knowledge, we have conducted that this is the physics of a ghost, and this is what a ghost is made of. And we are also going to be covering some of the equipment that we are using and or building. We're going to be covering the physics on those as well after we are done with covering all the physics and all the basic stuff about a ghost. Alright, let's get started. A ghost, we have, concluded, is made up of pKe bonds, which is psychokinetic energy bonds. We predicted that is one proton and two electrons around it per molecule. And that's bonded together by hundreds of millions of, probably billions of those. And I want to just say that there's a couple ways to destroy this bond. We're also going to be doing a couple mixes of how equipment would work with this. So why don't we start off with the proton pack, or a proton particle accelerator, because I feel like a proton pack is kind of cheesy to say, I feel. So we're going to go with a more, sci-fi, or actually not a sci-fi, but more of a scientific term for it, a proton particle accelerator. This disperses a beam of protons and accelerates protons at a very high speed. So, hydrogen is made up of two subatomic particles, a proton and an electron. So when protons collide with the psychokinetic bonds, or the pKe bonds, it steals an electron from each molecule of the ghost. So, one molecule of the ghost is two electrons, one proton. So it bumps into it and steals the electron and ionizes it. And what that is pretty much saying is, it's kind of like a fancy word for almost destroying, or disintegrating. Well, less of disintegrating. But it breaks it down, or shall I say, ionizes it into hydrogen. And that disperses in the air. So it makes it weaker, it kind of just breaks it down, destroys it. And that's what our proton pack, or our proton particle accelerators, are for. Now, there is also another way to kind of break the bond between that without even using a full, proton particle accelerator, which is extremely hard to create and requires a lot of research to create. And you'd have to know it a little more than basic physics to actually know how to create this. But there's another solution that you can do, and that is using lasers. And yes, I'm talking about the laser that you'd use for maybe playing with a cat or a dog, or I don't know, some dogs like lasers. But mainly those lasers that you would put on a gun or play with a cat with to be more, not so violent. What a laser does is, when in between the molecules, it excites the electrons and breaks them away from the molecules and kind of disconnects everything. It doesn't really destroy it or ionize it, from what I know of, what we know of, but it just kind of excites it and disconnects everything. It still does a somewhat similar, damage of a proton particle accelerator, but it just doesn't ionize it. It removes the electrons from the molecules in the, pKe bonds, and kind of just disconnects everything and it just breaks apart and just everything goes its own way. Now, I am not too sure, and yes, I did say sure, but I'm not too sure if it could connect. I would have to research that. Now, let's move on to our, gear and equipment that we would use and that we do use. Why don't we go ahead and start with the proton particle accelerator? That's the thing I've talked about a little bit, but why don't we just start with the basic? So, on a proton particle accelerator, or in our case, kind of like a proton pack, there is something called a cyclotron. And that is actually the biggest things on the proton pack. That takes one of the biggest, in fact, that is the only way to make a particle accelerator. You need a synchrotron or a cyclotron. But in this case, it's a cyclotron. So picture two Ds. Okay? Put them side by side. And they're hollow Ds. And then a South Pole magnet is placed at the top, and a North Pole magnet is placed at the bottom, or vice versa. Now, what these magnets do is they press down, so it kind of stabilizes it. So the North Pole magnet is pressing or pushing a force inwards on the cyclotron, or on the Ds, and the South Pole magnet is doing the exact same thing, just one's on top and one's on bottom. Now, what the Ds are doing is there's a gap in between, and usually it's in a container. All of it's connected with the magnets on top of the Ds and into like a solid circular cylinder container that's vacuum sealed, keeping any neutrons or electrons or any particle you don't want into it. And the gap in the center is so there can be the charged particle that you were using, the particle accelerator, can go in between the gap. Now there's something called an oscillator, and that's connected to both Ds. And what that does is it switches let's say the right D positive, the left D negative, and then it switches where the left D is negative and the right D is, vice versa. So one D is positive, the other D is negative. The oscillator switches it real quick, so the one that was positive is now negative, and the one that's negative is now positive. It's so that the proton, gets attracted to the negative side. So then when it goes to the negative side, it switches to the positive side. It switches to the other side that will become negative. So the negative side will pull towards that, then it'll switch where that negative side that was negative turns positive and the other side's negative. So it'll go to that. And it spins in the circle and the spiral gets bigger and bigger and bigger, and then comes to an end where it goes through a cable that goes to the particle accelerator, the actual thing that accelerates the particle through a giant stick pretty much. But before you can actually get a proton through to the cyclotron, you have to go through a system where you take hydrogen gas and you ionize it down to protons, run it through a tube on a vacuum sealed, cylinder that's hollowed out on the top of the cyclotron in the dead center, right where that gap is. So a cable runs into that, like a tube, hollow tube runs into that, connecting to the ionization chamber, and the protons run through that cord, that cable, and goes to the middle of the cyclotron where the oscillator spins it and it goes to the cable. Now, the particle accelerator wand, shall we call it, has magnets in it where one switch will turn on two negative magnets, and those two negative magnets will hold it in place. And then one in the back will turn on when you want to accelerate the particles, forcefully pushing the particles through forcing the particles to come out the barrel of the little proton particle accelerator wand thing, whatever you want to call it. But that is the basic physics behind some of our, equipment that we use. Now, there is other equipment we could talk about, but time is, we're running out of time, so I would just like to say thank you guys all so much for listening to this podcast. It's been amazing to do this, and I like talking about this. If you guys want to learn more about this, please go ahead and check out our podcast that will be coming out soon. Otherwise, guys, have a great day or night. Depends if you're falling asleep to this or driving to work or going somewhere or just doing something. Thank you guys so much for watching or listening to this podcast, and have a great rest of your day or night. I will see you guys on the next podcast.